Alright, so let's pick up where we left off on the last Powershift transmission video for heavy equipment. That seems to be what everybody wants to hear about. So I'm in the same book as I was the last installment of Powershift transmissions, and we're going to talk about how the power from the engine gets to the Powershift transmission. And that would be through either a torque converter or a fluid coupling. So how does that work? Best explanation I can give, or the simplest explanation I can give for a torque converter or fluid coupling, is this diagram right here at the bottom corner of this page. If you take two box fans or you know your portable fan, some people like to sleep with those things on. I think everybody's familiar with that type of fan. But if you take one and point it directly into another fan, if you only turn on one of the fans, the air coming out of the blades of one fan will cause the blades of the other fan to turn. So how does that relate to a torque converter or a fluid coupling? Well, instead of air, we have the hydraulic fluid that is in the rest of the Powershift transmission, and the pump supplies the torque converter or fluid coupling with that hydraulic fluid. When the torque converter or fluid coupling has the hydraulic fluid inside, just like the two fans facing each other, there's one fan, air quotations on that comment there. One fan is connected to the engine, and the other is connected to the input shaft of the Powershift transmission. So when we start the engine, the blades of the fan connected to the engine start moving that hydraulic fluid. When that hydraulic fluid starts moving, it gets directed into the blades of the fan connected to the input shaft of the transmission. As the RPM increases of the engine, the velocity of the hydraulic fluid inside the torque converter or fluid coupling starts transmitting more and more energy into the input shaft of the transmission. So the two fan analogy is the best way, in my opinion, to describe what's going on inside there. So if you guys have ever seen a torque converter, I think the torque converter is more widely known, or most people have seen a torque converter. It's kind of shaped like a donut without the donut hole punched out of the middle. So the shape of the housing of the torque converter actually causes the fluid to spiral. So as it leaves one set of blades of the fan on the engine side, it follows the shape of the housing, and it enters the blades of the other fan connected to the transmission and exerts that energy into the fan on the transmission and starts turning the input shaft of the transmission. And that fluid that has now went from the fan on the engine to the transmission, because it's following the contour of the housing of the torque converter, it circles back around. Once it passes into the blades of the transmission side, it gets slung back around back to the engine side of the torque converter. I mentioned torque converters and fluid couplings. There is a difference between the two. With a fluid coupling, we just have the two fans. With a torque converter, we add another piece into the mix. Let's see, where is my diagram of that? Well, they don't really give us the best diagram of that. But in a torque converter, we're basically adding another piece between the two fans. And that fan is a stationary fan. It is locked in position. It cannot rotate. It is actually suspended between the two fans by a piece that usually is around the input shaft of the transmission, and it's stationary. It's attached to it's actually attached to the housing of the pump on the front of the transmission. So it's stationary, and what it does, the blades on that piece in between the engine and transmission fans, it helps direct the fluid at a better angle. So as it passes through that piece, the direction of the fluid is changed so that when it impacts the blades of the fan that's on the input shaft of the transmission, we're getting the most energy collection we can out of that fluid hitting the blades, and essentially transmits more power from the engine to the transmission. Another good diagram we have here is this guy down here, and that piece in the middle between the engine and transmission fans is called the stator. So in this diagram, they're showing with a water hose here, another kind of good example. If you take a water hose and shoot it into, well, they give us an example up here. If you have like a wheel connected to a paddle wheel and you spray it with a water hose, it's going to spin that wheel. Depending on the angle we engage those blades with that water hose is going to change the speed of that wheel. So what the stator does is essentially change the angle of that water hose. So why use a fluid coupling or a torque converter rather than a clutch like a manual trans? Well, that's just another control that the operator has to deal with. If you've ever started a manual transmission on a hill, you have to feather the clutch and slowly apply the power to the transmission to keep the vehicle from rolling back. With a fluid coupling or a torque converter, we've always got some energy being transmitted to the input shaft of the transmission. What's good about the torque converter or fluid coupling, when we have our foot on the brake, even though we're in gear on the transmission, when we're at idle, the velocity of the fluid is quite low inside the torque converter or fluid coupling. So yeah, we're transmitting some energy into the transmission, but that can be overcome by our foot on the brake. And that energy still has to go somewhere when we're holding the input shaft of the transmission through holding the brake, and it turns it into heat. When we have energy, it always has to go somewhere. So in this case, when we're holding our foot on the brake and we're holding the input shaft of the transmission from spinning, we're essentially taking that fluid velocity coming from the engine, and it's still hitting the blades on the fan for the transmission. It's just being converted into heat. But the great thing about this whole setup is when you let your foot off the brake, that little bit of energy that it was being turned into heat immediately starts to rotate the input shaft of the transmission and starts to move the vehicle. So It's just one less thing for the operator to worry about. When we change from forward into reverse, we already have that energy there going into the transmission. So it kind of plays into the advantages of the Powershift transmission itself, in that it's kind of a quicker setup. When you're working on a job site and going back and forth and moving not very far distances and a lot of forward and reverse, operating that clutch pedal would, believe it or not, slow the operation down a bit. Plus, a lot of stop and go operation of these machines, it's going to wear out a clutch pretty quick. I don't care how good you are on a manual clutch. That clutch disc is going to get worn out over time. The more you actuate that clutch, the quicker it's going to wear. What else happens when you operate that clutch? Well, when you apply pressure to that clutch, you're actually pushing the crankshaft of the engine fore and aft. So every time we push that pedal and release it, we're pushing that crankshaft into the thrust bearing on the crankshaft of the engine. And then when we let our foot off, it's the crankshaft's having to move back. So not only are we wearing out a clutch disc, we're wearing out the thrust bearing inside the engine itself. So fluid couplings and torque converters kind of play into that ease of use that a Powershift transmission provides, as well as cost of operation. You're not changing clutches all the time, and it's quicker. So remember, the only difference between a torque converter and a fluid coupling is that piece in the middle called the stator. And just to bring it all back into and bring it all to a conclusion here, we've talked about the middle piece. That's the stator. Well, the whole time I've been referring to these other pieces as the fan connected to the engine and the fan connected to the transmission. So what are those actually called? The fan connected to the engine is called the impeller. The fan connected to the transmission is called the turbine. So we've got the impeller, the turbine, and the stator. And then the housing itself. And that's just about it with a torque converter or fluid coupling. One thing about that stator in the middle that I've failed to mention thus far is the one-way clutch. So that piece in the middle, it is able to turn. So when we have our foot on the brake and we're holding that input shaft of the transmission, that fluid's being turned into heat. Well, if it's a torque converter, we have that stator in the middle. Well, when the turbine on the transmission's not rotating, that stator is taking a lot of energy. It's getting a lot of energy transmitted through those blades on the stator. So when the vehicle's sitting still, that stator is able to turn. It's able to turn backwards. That one-way clutch is able to allow it to spin that opposite direction. As soon as we let our foot off the brake and we allow that fluid to start turning the input shaft of the transmission, that the one-way clutch on the stator locks. So as the fluid passes through that stator, it applies force to the blades on that stator, and the stator wants to rotate the same direction as the input shaft on the transmission, but that one-way clutch stops it from rotating and thus directs that fluid at a better angle into the turbine of the transmission side. So I hope you guys have got a little bit better understanding of a fluid coupling or a torque converter. Next video I'll get into torque dividers and how they kind of play into torque converters. We're just adding some more parts. But stick around. Be looking out for the next one. Like and subscribe if you haven't. Keep a lookout. And I'll get you guys that next video next week. Thanks for checking us out.